Hello and welcome to one more Meet the Scientist session. We're welcoming in classes today from Montana, from North Dakota, and from the great state of Alaska. And our presenter with us today is Dave Verbyla from the great state of Alaska itself. So I'll let everyone say hello in just a minute. But let me first tell you that I am Bonnie Murray. I'm actually sitting at NASA Langley Research Center. Let me come over here. But you're not seeing NASA Langley Research Center behind me. You're seeing the International Space Station. So it looks like I'm out in space without my spacesuit. But actually, I'm in the studio here at NASA Langley. And the reason we selected to have the ISS behind me is because we're going to be talking today about remote sensing. And there is actually instrumentation on the ISS that does some remote sensing. In fact, one of the other Meet the Scientist sessions that we had talked about SAGE 3, which measures ozone, the entire column of ozone through the atmosphere, and that instrument is on the International Space Station. So you can go back and watch that recording at some point if you want to. I need to do some thank yous before we go any further. Speaking of all of the Meet the Scientist sessions, I need to say thank you to NASA's Science Mission Directorate. They are the funders of this session and also the program that runs out of University of Alaska Fairbanks, which is the Arctic and Earth Science Project. And Elena Sparrow leads that project up there. Melinda Chase and Katie Spellman also work with her. So it's a wonderful project. If you don't know anything about it, you'll be able to find information on the page where this recording is. And just Google Arctic and Earth Science and you'll be able to find it there as well. So Meet the Scientist sessions. The idea is that we want to bring scientists into classrooms, and it's hard to physically go there. So our goal today is to have students that are connected, and you can all wave. We'll get you to say hello in just a second. But the exciting part is we're going into the virtual world to be able to talk together. So this is as close as we can be. We're all in the same virtual room, just not breathing the same air. And so we're going to take some time to chat today with Dave and get some thought from the classes as well about what it's like to be a scientist and what kind of science is being done by Dave. So let's start by introducing everyone. I'll go first over here to Stacy. There we go. Hi, Stacy. Let me get your picture large. I think I did that. All right, Stacy, hi. Tell us where you're connecting from. I might have already given that away. And what kind of science you're involved with.
Hey, Bonnie. I'm from Turtle Mountain Community College in Belcourt, North Dakota, right up next to the Manitoba border.
Right, almost into Canada. Yeah.
Yeah. So we're going to be looking at phenology projects and starting in the spring. And then next summer, we're going to be looking at plant populations of traditionally significant plants. And then in the fall, we're going to start the winterberry study. So looking forward to that. And I'm looking forward to this presentation for Landsat and how we can incorporate it.
Great. That's awesome. And so one of the things I want to point out while we're talking to Stacy is Stacy's at Turtle Mountain Community College, and Stacy mentioned bringing in the cultural elements, the cultural significance of plants. And that's a big part of the Arctic and Earth Science Project, braiding the Western science with traditional knowledge. And so you'll hear that mentioned several times through the broadcast. And again, the project itself is focused on that. So take a look at the website also and learn more about that. All right, thanks, Stacy.
Thanks, Bonnie.
All right, let's go to Polson, Montana. Let me work this out. Okay, and in Polson, Montana, we have Miss Wyman and Miss Ayers' class. There they are. Hello. So if you'll unmute and tell us a little bit about what you're studying in science and that kind of thing. Go ahead. I think you're still muted. I don't hear you yet, but we'll get it. Okay.
Hi, my name is Alicia. Our research is researching the effects of climate change on our bitterroot and berries and temperature and precipitation.
Awesome. Thank you so much. Have you started your research yet, or is that yet to come?
No.
Yet to come. All right. Great. Good. Well, I'm glad you're connected to Dave today for two reasons. First of all, you're in Polson, Montana. You're not in Alaska, but one of the other really important elements of Arctic and Earth science is that what happens in the Arctic doesn't stay in the Arctic. What happens in the Arctic affects everywhere. And so we'll be talking about that a little bit today too, change over time and how change in one location can cause change in another location. It's all one globe and the pieces are interconnected. So thank you for that information. We'll be back to you in just a minute. All right, now let's go over to a class that is connecting from Alaska. Hello. All right. So we have Miss Trotsky, who you're seeing right there. Thank you for unmuting again. And also there with her is Miss West and Mr. Fuentes. So 3 classes. Thank you all for sitting so close. Hello. Tell us a little bit about what you're studying.
Hey, right? Come over here. You got to be able to see. Come over here, okay?
Right in front of the, it's in front of the computer.
No, you're gonna squat down.
Squat down a little bit. There we go. Hi.
Computer.
What we have been learning about is what sensors are used for clouds, and opposites have been measuring temperature, winter, and rain.
Temperature. Let me make sure I got those. Did you say temperature?
I said temperature, winter, and rain.
Oh, okay. Awesome. Awesome. Thank you so much. Have you started the measurements yet, or that's going to be happening later in the year?
We started.
Oh, wonderful. Okay, great. All right. Well, thank you so much. We're going to let Dave give you some information, and we'll come back to you for some more questions. Thank you. Awesome. Okay, so that's really relevant that they're collecting because in order to connect temperature and rainfall, they're measurements you collect on the ground. Sometimes we call those in situ, right? Like on the ground. But Dave's going to be talking about kind of zooming out and getting the picture from a higher place in the atmosphere than what you can get on the ground. So Dave, I'm going to switch over to you and let you say hi. Dave Verbyla, here we go, is our presenter today. And Dave is connecting from Alaska, and I can see the sun is just starting to come up over Dave's shoulder. You can kind of see that out there. It's not quite daylight. It's a little bit of a cloudy day, huh, Dave?
Well, I'm looking at blue sky.
Okay.
So I'm looking to the north.
Oh, okay. All right. I guess it's because we're looking out the window. Yeah. So Dave is a researcher who uses NASA Landsat data as he studies. And he actually sits at the University of Alaska Fairbanks. So he's connecting from that area this morning. So Dave, I think we'll go right into your presentation, if that's okay.
That's fine.
All right, great. So let me go back over here and I will share that. Couple clicks away. All right. Are you seeing that presentation?
So can everybody hear me?
Thumbs up if you can hear Dave.
Okay. So I'm a scientist and I am connected today with schools from North Dakota, Montana, and Alaska. And I actually have connections to all 3 states. My wife is from North Dakota, so I have relatives in North Dakota. And then I spent a year at the University of Montana in Missoula, which is just south of Polson. So I'm familiar with Montana, and I have relatives in Montana in Lolo, Missoula, and Superior. And I've lived in Alaska for the last 26 years. So I'm very familiar with the North Star School over there in Fairbanks. So let's go to the next slide. So as a scientist, I get to explore, and that's sort of my nature, is I love to explore canoeing, berry picking, fishing, hiking. So in my spare time, I spend a lot of time just exploring. And in my professional time as a scientist, I spend a lot of time exploring using remote sensing. So if we go to the next slide.
And as I switch, I'm wondering, in the classrooms, if you like hiking, raise your hand. If you like going outside and hiking, yeah, I know. I really like to hike too, get up close and personal with the plants. Thank you. All right, next slide.
So who here has flown in an airplane? So lots of students have flown in an airplane. So the nice thing is when you're in an airplane, you look down and you have a totally different perspective. You see things that you might not see from the ground. So it's a great way to explore. So if you take that one more step, and if you explore from outer space, we can use satellite imagery to sort of look at a much, much bigger picture. So if we go to the next slide, that's basically what I do is I use satellite imagery, which is taken from outer space, to look at really, really big, big pictures. So if we go to the next slide, this is a Landsat satellite image of North Dakota. And Turtle Mountain is on this satellite image. It's the big green patch that's sort of the left, right there, that big green patch. So why is that patch so green compared to the rest of North Dakota?
All right, so if either one of the schools, I'm not going to let Stacy comment yet because she's there. But if either one of the schools wants to take a guess at that, why do you think that patch would be so green? All right, I see hands up in Alaska. So Ms. Trotsky, she's going to be busy today. If you want to unmute and let those students give an answer, that'd be great.
Okay.
Oh, if she can get up there.
All right, what do you think? Do you have a guess? I'm not hearing your sound anymore. Did you have a guess at why that area, and I'll mark it again, would be so green? Uh-oh. I have to say, it looks like their connection's frozen. Let me hold that thought for a second. I know they got some new internet there, and they were worried about it. They just got a new internet installed. Anyhow, let's go over, while we're figuring that out, let's go over to Montana. Do you have a guess at why that area might be so green?
Hi, my name is Artie, and I think it's because that it has a lot of grass.
Excellent answer. Would that be the reason, Dave? Does that have anything to do with it?
Let's ask the person from Turtle Mountain.
All right, so Stacy, what do you think?
Pretty close. What else could it be?
You're not connected.
What do you any other guesses out there in Montana? Besides grasses, what else could be there?
My name is and I think it's because that it's closer to the satellite.
Oh, what room are you, Paul? 103.
All right, so I heard you say something about the satellite. Did you catch it, Dave?
I think she said because it was closer to the satellite.
Oh, because it's closer, because it's a mountain. Thank you. And thanks for shaking your head so we can see. All right. And I see Miss Trotsky's class is connected again. Did you have a guess there? I see hands up.
All right. Okay. We had a guess that the mountain area is more lush and higher elevation.
All right. Okay. Back to Stacy. What do you think?
Yeah, we have a really beautiful forest here. It's one of the few places in North Dakota that is forested.
Cool.
Good. So lots of trees in Turtle Mountain.
So it's really the tall foliage, the trees that the satellite is seeing. Is that right, Dave?
Correct.
Uh-huh. Okay. That makes sense.
Okay,
Yeah.
let's go to the next slide, which is from Montana. So the lake, what's the name of the lake that we're seeing in the upper part of that satellite image?
Right here. Okay, I see some guesses from Montana. Go ahead and take a guess. Or tell us. How about that? No guesses needed. And I don't even think they practiced, Dave.
No. So if we go below the lake to the left, it's sort of a pinkish color. So why is it not green? Why is it sort of a pinkish color in that area on the satellite image?
Any guesses?
Hi, my name is Morgan, and I think it's because it has more dirt in that area.
Okay, and let's see if there's a guess up in the classroom that's connecting up in Alaska. Any guesses there? The guess we have so far is that because there's more dirt.
We're good. Go ahead. Okay.
I think it's the cannon. I think it's a cannon.
Okay. All right, Dave, what do you think of those two guesses?
And then if we go to the right, why is it green to the right?
All right, and Stacy, do you have any guesses? So we see a lot of green over here and more pinkish color over here. We had a guess of more dirt here and kind of a canyon there. And then why would it be green over here? Do you have a guess, Stacy? Oh, well, I see a lot of the kids with their hands up in those classrooms too. Stacy, if you do have one, you can unmute. I'll come right back to you. But let's go to Montana first. Why is it green over here?
Hi, my name is Jaden, and I think it's more green because of the mountains and because they have a lot of trees on them.
Okay, good.
Aha, all right. Any guesses from Alaska?
I think because of more grass.
Okay, thinking more about that grass again.
So if we look at the lake, there's a river coming down from the lake. And to the right of the river is green, and to the left of the river is pink. So why would it be green to the right of the river and pinkish to the left of the river?
Dave, I'm noticing something else. If I could have a guess too, it's kind of wrinkly over here. Right?
Right.
Yeah, so I wonder if that wrinkliness has anything to do with it. All right, guesses. There's you can unmute. Whichever. Let's go to Alaska first this time. I think I see you unmuted. Go ahead.
I think it's the water going down through the mountains.
Okay. Thank you for your guess. Yep. And I think the classroom in Montana is ready. Go ahead.
Okay. Hi, my name is Kane, and I think it's more green over on the right side because the water probably flows through the grass.
Okay. All right, Dave, what do you think?
Okay, so point your arrow to the green to the right of the river. So that is the Mission Mountains. So that's forested. And then if you go to the left a little bit, that's the Flathead River Valley. And the pink is area that's not irrigated, but to the right is irrigated. So just to the right of the river, that green is irrigated. So that's the big difference is we've got green vegetation versus vegetation that's not irrigated. It's what's called senescence, where the grass turns yellow. because it's not getting enough water, so it basically becomes dormant for the summer.
So it does have something to do with the grasses, but the big difference, I want to make sure I got this right, the big difference between here and here is, whoops, I switched to the next slide, is that this is irrigated, and so it gets nice and green, and this is just the natural flow.
Not irrigated rangeland.
Yeah. So it is tied into those grasses, but elevation plays a factor as well. We got a lot going on. Okay.
Okay, so let's go to the next slide, which is near Fairbanks. So where is Fairbanks on this satellite image? It's not in the middle, I'll give you that hint. And the river is the Tanana River that we're looking at. And we're looking at from outer space, so we're looking at a really big area.
Right, even higher than you'd be in a plane. That's the thing we can think of. Aerial, we talked about have you been in a plane, but this is even higher up than the plane would see. So more zoomed out. So where should I go for Fairbanks? My arrow is moving all around. What do you think? Anybody in Fairbanks have a guess? Or the school that's in Alaska near Fairbanks? You can direct me, move up, move up, move up, or move down, move down, move down. You tell me where to put my arrow.
You want her to tell her to go.
Up there in the mountains.
Okay.
Okay, and how can you tell you've already picked something up. How can you tell where the mountains are? What does it look like where there's mountains?
The top.
What does it look like, though? Remember the word?
Wrinkly.
There you go.
Yeah, look at that. Wrinkly. The wrinkliness tells you that there are mountains there. Good job. Yeah. All right, so Dave, they're guessing up here.
Okay, Fairbanks is on the Tanana River, so that's a good hint. So the river is, what is the river look like? Okay, so there's the river. So it's somewhere on the river.
So that's kind of smooth, isn't it? The area right around the river there. So wrinkly we can tell is mountains. We're figuring out how to read satellite images, and more smooth areas because it's flatter around the riverbanks. All right, so I'm going to go along the river. Dave, do you want to tell me when to stop when I get to Fairbanks?
If you go all the way to the left on the river, that's Fairbanks right there.
Okay.
So then if we look, we see some brown patches, and then we'll see green patches. So why do we have brown versus green patches in Alaska? So what's causing those brown patches compared to the green patches?
Okay, let's see if Montana has a guess, and then we'll come back to you in Alaska. Any guesses from Montana? See this brown?
Hi, my name is Natalie, and I think the difference is because one part doesn't get enough water, so some of it turns yellow, like you said, and then the rest of it gets a lot more of the water.
Okay.
All right, good guess. I like these guesses. Awesome. Let's go back up to Alaska. I think they're ready to unmute. Go right ahead.
I think because when it's like slipping down and the water's going down, the grass gets more water than the top does because the brownness isn't really near that much water.
All right. Great thinking. I like the way you explained all that you're thinking also. Thank you. Appreciate that. All right, Dave, fill us in a little bit more.
So some of the brown is due to wildfire. So the wildfire burned a big area and the trees died. And then you have fireweed and grasses that are revegetating the area, but they have a lot less leaves than the trees would. So from outer space, even though there's growing fireweed and growing grasses, it's not as green as the trees would be from outer space. So the areas that we see are green are all forested tree areas. And a lot of the brown areas are either shrubs or places that were burned in the last 10 years or so. And they'll eventually become trees, but that's going to take many, many years for the areas that burn to become forested. So a lot of it has to do with wildfire in Alaska.
Mm.
And if you go to Fairbanks and go north, there's a little patch that looks different. So does anybody know what that little patch is north of Fairbanks there?
I see some guesses. Go ahead and unmute, Ms. Trotsky. Oops, I did it again. My mistake, but we're right there. All right, what do you think? There's a little patch here.
I think it's like just sand and mixed together.
Ah,
Okay, so there is sand there. So what's causing the sand out in the mountains like that?
Can I
This is
make
a
a
hard-
guess?
Yeah.
absolutely.
Is it Fort Knox gold mine?
Yes. And what is Fort Knox? What do they mine at Fort Knox?
It is a big pit that they're digging gold out of. And so they're
Right.
digging into a mountain. Yeah.
So that's a gold mine.
Wow, so we're seeing that the actual where they're digging is what we're seeing there. It shows up from space as a hole in the greenery. Wow, very cool.
Okay, so let's go to the next slide. So I use these satellite images. I can go back in time and look at how things have changed since the 1970s. So the satellite images I use are part of the Landsat satellite mission. So there's been 8 different satellites since the 1970s. And that's why you have the numbers Landsat 1 through Landsat 8. So it allows us to go back in time. So let's go to the next slide. So as an example, we can look at how lakes have changed over time. So the black here are ponds and lakes. How have they changed from the left image to the right image? Are they expanding or are they drying up? So water is black on these satellite images.
Mm-hmm. Okay, so I see both. Whoever unmutes, you can, either one of you can unmute, it'll be okay. Because I know it takes a minute to unmute. So go ahead and unmute and guess. Go ahead.
My name's Cameron, and I think that it's dried up.
Good.
All right, and what do you think over in Alaska? Take a guess, someone? I see someone coming up.
I think that it is shrinking.
Good.
Mm.
So let's go to the next slide, which shows you what it's like on the ground. So there's the lake, and it's shrinking. It's drying up. So we can see that from satellite. We can map across an entire area. Where are these lakes drying up? So the question is that good or is that bad that these lakes are drying?
All right, I think if you want to unmute in Alaska, and then we'll go to Montana next.
Yeah.
No? Just wait till they...
It's that it's dry.
And why is it bad?
Because maybe some fish live there.
Oh, that's a good one. Fish.
Yeah, that's true. Would not be good for the fish. Okay, go ahead in Montana.
Hi, my name is Christian. I think it's a bad thing because if the water soaks down, it'll get all muddy, then it would keep you away from fishing, and it'd be bad because the fish is in the circle of life, and it would just make a really bad, like, I don't know.
Yeah. No, I got your point. I know. I appreciate you sharing all of your thoughts. So definitely not good for the fish. If the water's going down, the fish are really going to struggle with that. Yeah. Dave,
Now,
I'm thinking you have some
how
reasons
about
that it's
moose?
good
Would it
also.
be good or bad for moose?
Hmm. Go ahead, Shauna's class.
What do you think? Good or bad?
I think it's bad for moose because moose drink out of.
Okay. So the moose that are drinking out of that lake can no longer drink out of that lake. All right. How about in Montana? What are your thoughts?
Hi, my name is Olivia. I think it's bad for moose because they could sink when they're walking,
Okay.
and yeah.
Okay.
How about shorebirds like sandpipers or cranes or plovers?
Any guesses from Montana while you're already unmuted? How about those birds? Good or bad for those birds? Great. I like the way you're coming up to the front. And I'm glad you're telling us your names as well. I like getting to know you a little bit. Thank you.
Hello, my name is Jonathan, and I think it's bad for the birds because if they land in it, then they could their legs could sink into it, and they won't be able to fly away, so they don't have anything to do.
All right. Thank you very much, Jonathan. How about Alaska? Any guesses? Good or bad for those birds? I think you're still muted. And Montana, it looks like you're still unmuted. Just keeping you guys aware. Okay.
My name's Amelia. It's bad for the birds because if the birds see them put them food in it, they'll dive down and their wings will get all muddy and then cat will fly.
Oh, I didn't even
So
think about
how about
that.
we go into the future? Let's go into the future, and it's no longer mud. That now you have grasses and willows growing as it dries up. Would that be good or bad to have grasses and willows in this area now? So it's no
Okay.
longer mud, it's now soil, and it has grasses and willow shrubs.
Right. So thinking about this change over time. So time passes and now it's dried up even more and plants have started to grow up there. Alaska, let's start with you. What do you think? Let's go back to those birds. Is it good or bad for those birds if there's some shrubs around?
Hi, my name's Olivia. I think it would be good because there would be more sorry. There would be more land for animals to be, more ecosystem.
Okay, good.
All right. Good thoughts. All right, Montana.
Hi, my name is Trinity. I think it would be good for the animals because they can walk on the land and land in the trees and have feed.
Thank you very much for your guess. Back to you, Dave.
Okay, let's go to the next slide. So the other thing we can map over time are wildfires. And when I left Fairbanks to go to Montana for a year, it was 2000. And I left Fairbanks in August. It was smoky from the wildfires. I got to Montana, it was smoky from the wildfires. And it was so smoky in Montana, you could not even go fishing or rafting. They closed all the rivers down because of wildfire danger. So that was in 2000. So Fairbanks and Montana both have summers where we have lots of wildfires. And it's easy to map where these wildfires burned and how severely they burned over time. And it's easy to map what kind of vegetation regrows after the wildfires. So let's go to the next slide. So here's an area that's a forest that was burned by a wildfire. And if you imagine in the future, you'll have revegetation of this area. So is that going to be good or bad if you have revegetation after the wildfires?
Okay, so things will start growing back up after the wildfires. What do you think? Good or bad? And let's start with Montana this time.
My name's Bradley, and I think it's good because when the trees burn, the seeds drop, and that helps more trees to grow. So.
All right, thank you. So the seeds were spread all over during the fire, and when things start growing again, we'll start to see those trees come up. Thank you, Bradley. All right, over to you, Alaska.
Hi, my name is Anne and Adeline, and I think it's good for once it grows back up, but I think it's also good if the seeds spread so it can be so it can grow up in different places.
Good.
All right, back to you, Dave. And just like, as we come back to you, just like we talked about with the birds, more places for them to walk around. I'm not sure we actually closed that loop, but that is a good thing, that there would be more places for the birds to be able to nest and things like that as things start to grow back up.
Okay, so let's go to the next slide. So we can also use satellite imagery to look at how things have changed over time. So here's an example where shrubs are expanding across the landscape from the 1940s to 2000. So is that good or bad to have shrubs expanding across the landscape? So for example, in 1940s, the shrub was just in that little canyon system. And now the shrubs are on the hillsides. So we can map that using satellite imagery. So is that good or bad to have shrubs expanding?
And the shrubs I'm noticing are bumpy. So we talked about the mountains being wrinkly and the smooth parts being around the lake. And here we have some bumpy. The shrubs, and way more shrubs over here. So is that good or bad? It looks like Montana's ready. We'll go to you.
Hi, my name is Rhea. I think it's good because the water can flow down it, and then the grass can get more water.
All right. Good thoughts. All right, over to Alaska. Thank you.
My name is Jessica, and I think it's bad. Because
You think, I can see why you might think that there's some good and there's some bad. What bad thing is there? Let me know your thoughts. All right.
okay.
Can you help out a little bit, Ms. Trotsky? Maybe she'll tell you her thoughts. Yeah. What are we thinking?
Why do you think it's bad? What do you think? Why do you think it'd be bad for animals?
What would be a not so good thing?
Because I think they get stuck in the mud and they can't get out.
So animals might get stuck in it and can't get out.
Okay.
All right.
All right. Yeah. Maybe there's animals that wanted the clear ground to live on. Yeah. Thank you so much for your thoughts. Awesome.
Okay, let's go to the next slide.
All right. So there's good and bad to the shrubs, right,
There is
Dave?
good and bad to the shrubs.
Yeah, both good and bad. All right. Moving on to some snow.
So the other thing that it's easy to map using satellite imagery is snow. And both in Montana and in Alaska, some winters we have lots of snow. So this was from last spring. This is my barbecue. And the question is snow good or bad?
All right. People are thinking of snow days, Dave. Is snow good or bad? Either class want to answer? I'm looking for hands. We'll come to Alaska first, and then we'll come over to you, Montana. What do you think, Alaska? Come on up. There we are. Hi.
I think it's good because it sort of gives a blanket to the earth, and some animals can tunnel into it and it'll be like a blanket keeping them warm and a bit of protection from predators.
Yeah. Very good thoughts. Thank you. Yeah, so tunneling in and letting that be a little bit of warmth for them. Yeah. All right, over to Montana.
Hi, my name is Abby. I think that it really depends on like what the snow is doing. Like I think that it can be good for certain things but bad for other things.
Mm-hmm. Okay, that's very well. I guess we're going to find that out, huh? Go ahead, Dave. Good for what and bad for what?
Well, let's go to the next slide.
All right.
So we can map in the spring, where is the snow melted off and where is the snow still going? Every day we can map where the snow is. So here's a map, for example, the last day of spring snow. In some places it's gone in April. In other places high in the mountains, it might not melt until July. And the same thing in Montana. You might have snow gone in April in the valleys, and it might not melt in the mountains until late June. So in the spring, for some perspective, it's good to have snow, and from other perspectives, you'd like to have the snow melt. So why would snow melt be good in the spring?
Snow melt good in the spring.
Let's start with Montana. I think you're already unmuted. What's good about snow melt?
Hi, my name is Karen. I think it's good that the snow's melting because since there's a lot of fires in the summer, and if the snow melts, it keeps stuff wet and not make the grass burn.
All right. So it's good to water things. I like that thought. All right. How about over to Alaska? How about your thoughts?
I think that it's good because you can get more warmth in the snow. When the snow melts.
Then the land can warm up.
And the land can warm up.
Mm-hmm. So the land starts to warm up. Is that what you're saying? I think. Okay. Thank you. All right, Dave. There's some good on two different levels.
Good. Okay, if we go to the next slide, it's my last slide. And these are slides from my yard. And I've often wanted to ask moose questions. So the first one, this moose is in my garden. And it's a cow moose, and she's eating all my broccoli and all my peas. and she wouldn't eat the zucchini. So if I could ask her a question, I'd ask her, why aren't you eating the zucchini? And then the other moose is a little bull moose, and he's eating rose hips in the fall. And if I could ask him a question, I'd ask him, why are you eating those rose hips? So I'm just going to open it up, and if any students have any questions for me as a scientist, I'd be happy to answer your questions.
Excellent. Well, first of all, thank you, Dave. That was a great presentation. I like a lot how you had us think about what's good and bad. There's good and bad to a lot of the different changes that happen, so I appreciate that. Let's go to Turtle Mountain first, and Stacy, and I'm going to unmute my picture so you can see me again. Stacy, go ahead and ask your question.
Where would we find information if we wanted to get satellite images throughout a growing season?
Bonnie sent you a couple links. That would be a good place to start. And then you could actually download satellite images. There's a website, earthexplorer.gov, and you can download, that's where I downloaded, for example, that one satellite image of Turtle Mountain. And you can go back in time and download satellite images all the way from the 1980s, basically.
Mm-hmm. Right, so this is a good chance. Thanks for asking that question, Stacy. I'm going to highlight a couple of websites. The Landsat Science website is a good one to go to. There's also Earth Observatory that you can go to. And while we're here, I'm going to show you the Applied Sciences site. Has specifically some information about wildfires and how citizen scientists, which all of the globe measurements you're doing are citizen science measurements, how citizen scientists are really helpful in understanding wildfires. So partially to answer your question and provide some more information, Stacy, but I also wanted to show these for general knowledge as well. There's 3 great websites to find out more about Landsat, get Landsat images, and learn about how they're being used. Okay, let's go. Thank you, Stacy. Any other questions? I know Stacy has to sign off. Do you want to ask one more before you go?
Nope, just thank you very much. Thanks, Dave.
Thank you, Stacy.
Awesome. Thanks for connecting from Turtle Mountain in North Dakota. Awesome. Okay, let's go over to Montana. We'll stay in the lower 48 for just a minute, and we'll get a question from Montana. Go ahead.
What inspired you to do this research?
What inspired me to do this research? So I have always liked to explore, and as a scientist, I get to explore scientific questions, but I also get to look at what I'm doing my research on from outer space. So I like that perspective that I'm looking at a real piece of the Earth from outer space and asking scientific questions. The other thing I like is I can travel as much as I want to conferences and visit other scientists, so I can travel quite a bit. And I like that.
Mm-hmm. Awesome. I want to mention while we're talking about that working with other scientists is a big part of science. So as you in the classrooms start your globe research, and you're working with each other, and some days it might not be really easy, work through those challenges, because most scientists work with other scientists in doing their studies. So that's a good point to make as well, Dave. Thank you. All right, let's go up to Alaska for a question. Go ahead.
How long did it take you to learn how to read a satellite map?
And tell me your name before you stop.
My name's Kennedy.
Okay, hi Kennedy, thanks. So Dave, how long did it take you to learn? It's a little bit of skill. We learned today about wrinkly, bumpy, smooth, and how we can tell where mountains and things are, but how long did it take you to really perfect that?
Hi, Kennedy. I started with aerial photography, so a lot of similarity is interpreting aerial photography and then zooming out to much bigger areas. It's almost like looking at an aerial photograph. But then the other part of analysis of satellite imagery involves math. So inside every satellite image, they're composed of grid cells. And inside every grid cell are numbers. So basically, I use those numbers to do the analysis. So it took me a long time to take classes at universities that deal with fields like mathematics and statistics. So that's a totally different part of analyzing satellite imagery. But most scientists that work with satellite imagery, they're using math of some sort to do their analysis. So it probably took me my undergraduate degree, which was a 4-year degree, before I became really, really good at it.
All right, thank you for that question, Kennedy. Let's go back to Polson, Montana. There we go. Ask your question.
Hi, I'm Corbin, and how do satellites get data to a computer?
Aha. Tricky. Go ahead, Dave.
So the satellites have things called sensors.
I think you need to mute again, Montana. Sorry. We're getting
and sensors record numbers. So if, for example, you have water, the number might be low because water is not very bright. And if you have something like snow, the numbers are going to be very high because snow is very bright. So basically, that's how inside every grid cell, we have different numbers. And these numbers could be from invisible wavelengths, or the numbers could be from wavelengths that we can see with our eyeballs. But basically, we have numbers inside every grid cell that the satellites record from something called sensor or detectors. So that's sort of how it works. An analogy would be if you have a stud finder to find the 2x4s behind sheetrock, that uses a sensor to detect, okay, there's no wood, and then you move your sensor, and then it detects a stud behind the sheetrock, and then it makes a little beep, and that's where it detects the wood. It's the same idea with satellite sensors, is they have a detector that senses different wavelengths. So that's how we get our numbers from our satellites. And it comes, basically, we download it from websites, these satellite images that contain these numbers.
Mm-hmm. And before they get to the website, Dave, there's receivers. The satellites are communicating with receiving stations on Earth, correct?
Correct.
Yeah, and then they translate that into the images that Dave is able to pull up. And when Dave talks about wavelengths, have any of you in the classroom studied the electromagnetic spectrum yet? With infrared, just with a show of hands, if you have the infrared and the visible light, right? That's exactly the kind of wavelengths that Dave is talking about. So some are shorter, some are longer, and the sensors on the satellites are able to detect that, and that's how they determine the images. All right, let's go to Alaska for another question. There we go. Go ahead.
Say, my name is Harper.
My name is Harper. How does the sun affect the snow?
Okay.
Okay, so Harper, and the question Harper had is, how does the sun affect the snow? And in Alaska, we have our shortest day in December 21st. It's 3 hours and 42 minutes. And the sun just comes up over the mountain, and it peaks at noon, and then it goes down below the mountains. So we don't have much sun then, so it doesn't melt the snow very much. When we have our snow melt, it's typically in late April or early May, and we have long day lengths by then. So we might have 14, 16 hours a day length. So we have lots of sunlight in late April and May. So our snow melts very quickly during that time period because we have so much sunshine for so long of a period. So that's how the sun affects the snow.
Thank you, Dave. Okay, I'm watching the time. I'm interested in taking at least one more question from each classroom, but I know that we're right about at an hour, so if you have to go, I understand. So I'm going to start with Montana. Do you have time for one more question?
My name is Olivia. Will all these changes affect us in Montana?
Okay, so how are these different changes going to affect Montana, or will they have any effect? Because we talked a bit about things changing in Alaska. Dave, over to you.
So, Olivia, that's a good question. And one big change is in Alaska and the Arctic, the sea ice is shrinking. And as the sea ice shrinks, that affects the atmospheric patterns. So, for example, there's something called a jet stream and the polar vortex, and that's being affected by the shrinking sea ice, which is affecting climate in Montana and North Dakota and many places in the lower 48. So sea ice is very important, and we're losing sea ice, and that's affecting the climate throughout the lower 48.
So the short answer is yes.
Yes.
Thank you, Dave. Yeah, and thank you for that explanation. Yeah, good to know. Because it's easy to not think about that, I think. You know, it's easy to think it isn't happening near me. Okay, back to Alaska, and I think this will be our last question there. Go ahead.
How long have you been a scientist for?
Ah. And tell me your name. I didn't hear your name first, sorry.
Ella.
Hi, Ella. All right.
And I didn't hear the question.
How long have you been a scientist? And it was Ella that asked that question.
Okay, Ella, I've been a scientist since 1993. So that is about 26 years.
Awesome. Dave, do you remember when you first thought that maybe you wanted to be a scientist?
I think when I first went to college, I took some classes that I fell in love with, these science classes in college. So that was a long time ago.
Yeah, awesome. All right, schools, I need to know from you. You need to go, correct? Yes. Okay, so I'm going to wrap up by saying that as you're collecting your data and becoming scientists through participating in that, think about what you could do with that. You know, it could be that you want to continue to study science and be an investigator. It could be that you want to write about science. It could be that you want to draw about science. There's a lot of different fields involved in working with scientists. So think about how you might want to do that. Dave, I want to give you a big thank you. If we can do like applause. Yeah, Dave, it was wonderful to have you with us. I so appreciate all the time that you took to get ready for this and to share with the classes. And we're going to say a big goodbye. Let's go to Polson first, Montana. Let's see if I can get your picture up there. All right, let's wave goodbye. All right, and then we'll come up to Alaska. Let me see if I can get your picture up here. All right, bye to Alaska.
Okay, we're done.
Thank you for being with us today. Watch for Meet the Scientist broadcast coming up later in November, and check out the website for the recording. All right, thank you, everyone. Goodbye for today.
Bye.
Bye.